The broadcast is now starting. All attendees are in listen-only mode.
Good morning, and welcome to the LSoy Advisor webinar, Seedling Diseases Can Keep Your Soybeans From Popping, brought to you by the Illinois Soybean Checkoff. I'm Todd Steinacher, and I will be your moderator for this webinar. Just a few housekeeping items to start with. If you included your CCA number when you registered for this webinar and you stay with us for the entire presentation, your number will automatically be submitted for 1 CEU in Integrated Pest Management. If you are listening to this recording from a webinar, you will need to go to the Certified Crop Advisor website, log into your account, and self-certify your units. You can ask questions during the webinar by using the chat features in the dashboard on the right side of your screen. There will be time for questions and answers at the end of the presentation, but please keep your questions brief and to the point. Without further delay, I'd like to introduce today's presenter, Nathan Kleczewski. Nathan is a research assistant professor at the University of Illinois, and he conducts research and extension activities on plant pathology issues in the state, focusing on corn, soybeans, and wheat. Nathan received his bachelor's degree in ecology and organismal biology with the plant science emphasis from the University of Wisconsin-Oshkosh, and a PhD in plant pathology from the Ohio State University. His research interests includes general plant pathology, crop protection, disease management, disease identification, mycology, and microbial ecology. The screen is now yours, Nathan. Take it away.
Thank you very much. I am glad to be here today, and I'd like to thank the Illinois Soybean Board for inviting me to give this webinar. I have boarded up my office door so my 3-year-old and my dog do not barge in and make any sudden appearances during my talk. Today, it's going to be a pretty full talk. I'm going to speak at a pretty good clip. I like to provide everybody with a little bit of information. I know that we have some people that are more experienced in some of these things than others, and I want everybody to come home and have something that can make them a better producer, a better CCA, and more profitable and effective. So today we're going to be talking about seedling diseases of soybeans, and I think this is really good timing given the weather we've had. I know we're getting our soybeans in the ground in many parts of the state, and then we've had some heavy wet weather that has caused a lot of flooding in parts, and I'm sure we're going to start getting some calls about some of these issues in the upcoming weeks. Now, keep in mind, seedling diseases of soybeans are caused by many different types of pathogens. We have our Pythium species and our Phytophthora sojae and sansomeana. Keep in mind that these organisms are actually grouped right over here in this dendrogram. They're not considered true fungi. They're actually more related to chytrids and algae. And that's going to mean that their physiology is different, and they're also going to behave a little differently from the true fungi, which group out up here, and those are going to be our Fusarium, Rhizoctonia, and some of these other organisms. Also, because we are working in fields and these are environments that are very diverse, oftentimes these are going to occur as complexes. It means you'll have multiple species, multiple types of pathogens in a given field. And so managing them can be pretty challenging, but there's some things we can do to minimize some of the impacts that we have with these diseases. Oops. So our seedling pathogens are going to be very similar in some aspects and also different. So what's similar about these pathogens? Well, one, they're soil-borne. That means they're going to be resident in our fields and our soils. They're not going to be dispersing via spores on air currents or anything like that. They're not going to be moving long distances during the season. They're all going to be favored by excessive soil water. Anything that is going to prevent your seed from germinating or is going to reduce its ability to grow is going to favor a lot of these diseases. Plant stress is going to be a big issue, something we have to keep in mind. They all overwinter in residue as well as in the soil as specialized structures. These oftentimes are a spore type structure, makes them very tough and resistant, and able to survive all sorts of ranging conditions. They also, all of them, cause a root rot. And these root rots can have two different effects. One is they can impact your stands through pre-emergent and post-emergent damping off. That means that they are actually killing your seedling either before it reaches the soil line or immediately after, soon thereafter. Or if they start affecting the plant later on in the season, they can result in some reduced plant growth and yield. So you'll oftentimes see a lot of these diseases occurring in patches in your field, low-lying areas. You'll see dead plants, you'll see stunted plants. That's one potential indicator that you might be dealing with some of these organisms. But they're also different in many different ways. I already showed you that the oomycetes are different from the true fungi. And even within our different groups, they all differ in terms of their physiology, genetics, and that's going to play a role in how they interact with the host. That means you might have, for some of these diseases, resistance or tolerance, and for some of them we might not have anything. That can help. Host range also can be impacted, and this is all going to feed into our management options for specific seedling diseases. Now, I said they're all very similar in many ways. One is the disease life cycle. As I mentioned, they're all going to be overwintering in our soil, so they're already there when we're planting. We're going to plant our seeds, and at some point there's going to be some heavy saturating rains. And, a day or two of saturated soils oftentimes is all we need to get these going. The more water, the better in a lot of cases. And then when you have your seeds in there, they're imbibing water, and we have those heavy rains and the pathogens there. That's when that pathogen is going to emerge, and it's going to locate the roots and the seeds. And again, the timing's important. So the earlier this happens in the season, the more severe the impacts are going to be, because you can have direct impacts on your stands and impacting our growth early on in the season. They're going to be infecting those roots, causing their various disease symptoms and signs. And then when that plant usually starts to senesce, whether it's natural because it's reaching into the season or it's due to the plant being killed by the pathogen, that's when we start seeing the production of some of these overwintering structures, and that's where it survives the winter. Okay. So the first one that I'm going to talk about today is going to be the most common soil pathogen that we have in our soils in Illinois, Pythium. And Pythium, as I'm going to mention here, is very complex, and it's not super straightforward in terms of what we can do for it. Now, one thing to keep in mind is that this is a soil-borne water mold, loves it wet, loves it saturating soils because it produces a spore type that actually swims in water and detects those roots. So it will colonize the roots. It will cause what I call a mushy rot. And this results in the outer cortex of the root rotting completely. So if you pull these plants out of the ground, a lot of times that inner cortex will remain, and that outer cortex will slough off. Another thing you can look for is you can actually dig up the seedlings very carefully, get the root off, or get the soil off, and you can run that root between your fingers and it'll slough off. So this particular symptom here is actually called a rat tail. So keep in mind, whenever we see rat tailing, it's not a good thing. Don't get it confused with this sort of rat tail. That's also not a good sign if you see that, hopefully not in your fields. But that's going to be a good indicator that we're dealing with some issues with Pythium. Okay, again, low-lying areas, dead plants, mushy stuff. Let me move into my next slide here. So there was a survey that was conducted in the early, I'd say about 2011, 2012. And here what they're doing is they're just going in and sampling soil. You're not really paying attention to whether or not there's disease or not. And they're looking to see what kind of different Pythium are in the soils. And really what you need to get out of this is that depending on where you're at, okay, depending on what state you're in and what you're looking at, your composition of Pythium is going to differ significantly. And what that can lead into is that can lead into some differences in how aggressive and how severe Pythium can be. in a particular field or in a particular region. Now, Dr. Maduros in our department conducted a very small survey where they were just focusing on low-lying areas with dying plants, as well as samples that were coming into our plant diagnostic clinic that had symptoms of Phytophthora and Pythium infections. I'm just focusing on the Pythium here. And in the 3 years that samples were collected, you can see of those disease seedlings, there's a lot of different species of Pythium that can be recovered from them. So yes, from the disease seedlings, I'd say Pythium ultimum was the most frequently encountered, but there were also some other ones, for example, Aphanidermatum yorkensis, that we picked up quite often. That means we're dealing with a complex population of Pythium in our fields, and that's going to impact our management. Now, our different species are going to affect our soybeans differently. So in this particular study here, we took some of those isolates that we recovered from those plants, and then we assessed them for aggressiveness. So we have our disease-free control here, and here we're screening an isolate of Pythium Aphanidermatum, looking at whether or not it's causing the seeds to become fuzzy, if it's rotting the seeds, or if it's impacting germination. So what you can see looking across these different species is when you compare them to the control, yeah, they all can increase or reduce the percents, for example, germination relative to the control, but they might differ in terms of how well they do that depending on the species. The other thing that can be impacted is how sensitive some of these species are to fungicides, and that's going to impact the effectiveness of some of these fungicides on your soybeans. So in this case, we were able to screen some of these Pythium isolates that were pulled from those samples against a gradient of concentrations of some common active ingredients that were used or that are used to manage soybean seedling diseases. And in this case, I'm just going to pop up a couple of results that came from that. When we're looking at the entire population here, what we were able to see is that our Pythium vexins were insensitive to azoxystrobin as an active ingredient. So this here, this EC50 value, if it's far to the right, this is an example of something that's not being controlled, that is insensitive to the active ingredient. Here with ethoboxam, which is relatively new in our seed treatment toolboxes, you can see here that the Pythium Aphanidermatum isolates that were tested were very insensitive to that particular active ingredient. And there were also some that we'd consider to be medium in terms of their sensitivity, this torulosum. So even though we're getting the majority of our Pythium controlled by these active ingredients, some of these are not going to be controlled. If those are at high levels in your field, you might not see the type of efficacy that you're expecting. Temperature also can impact our species and the benefits that we see from our seed treatment. So in this case, we took our Pythium Aphanidermatum here on the left, and we incubated it in pots at either 59 degrees Fahrenheit or 68 degrees Fahrenheit. We did the same thing with Pythium ultimum over here on the right, and then we have our 3 treatments here. What you can see is that Pythium Aphanidermatum, this blue bar on the left, actually right here, at 59 Fahrenheit, it's not really having much of an effect on our emergence or germination of our seedlings. It's much more effective at reducing the emergence in our seedlings at warmer temperatures. However, when we look at our Pythium ultimum, it doesn't really care about the temperatures. It's able to cause disease at 59 and 68 degrees. And when you start to see that reduction in terms of the emergence, that's when you're going to see that benefit of that seed treatment. So in this case, the metalaxyl was improving the germination of the Aphanidermatum statistically at a significant level, not necessarily the ethoboxam here. And our Pythium ultimum, on the other hand, was significantly improved in terms of germination by that metalaxyl. And you saw more of a result when that was at the warmer temperatures. So what we need to keep in mind is that depending on our makeup of our populations and And when that water is hitting our fields, it can impact what pathogen is causing disease and how well those seed treatments are working. This is also evident in this study that we're looking at right here. So this earlier I showed you the survey that was done across multiple states. They recovered a bunch of different species of those oomycetes, and then they just are screening them for their ability to cause disease on soybeans at different temperatures, in this case 13C and 20C. And what you can see here is that a lot of them are going to be causing similar disease levels on the different temperatures, but there's also several examples where you have some that do very well at warm temperatures and poorly at cool temperatures, and vice versa. Maybe there's this one here, does well at cool temperatures and not well at a warm temperature. So what does this mean? This means historically we've always said that our fields are going to be more susceptible to Pythium issues when they're cool and wet. I'm not saying that that's not true, but I will mention that the data show that as long as we have wet weather, it's likely that you can still have Pythium issues at a warm temperature as well. And so the key here is going to be water as a component. How much water are you getting, and when is that water arriving relative to the growth stage of the plant? Earlier in the season, you're going to have those seedling emergence issues. Can't recover from that except maybe through some compensation of growth. But later on, we're going to be looking at infections that maybe are going to stunt our growth and our yield a little bit, but they're not going to outright kill the plant. So what can we do with our Pythium? Cultural management practices here are going to be important. We want to be minimizing compaction. We want to be minimizing the amount of standing water that we have in our fields if possible. If you have some fields where there's issues of spots of those fields that have major drainage issues, you want to try to address those, and if possible. I say here again, plant into warm soils. And the biggest benefit that's going to have is getting that seed germinated, getting it putting on real leaves and starting to produce larger root systems. The bigger the plant is, the more it's going to be able to tolerate Pythium root rot later on in the season. And then of course, seed treatments with a Pythium specific active ingredient. Keep in mind, different fungicides work differently on not only different fungal organisms, but on different species as well. These are oomycetes, so the oomycete active ingredients are going to work best. Ethoboxam rated excellent, mefenoxam and metalaxyl also work very well. There are some instances of metalaxyl resistance that have been observed in some areas. Whether or not that's at a significant level in Illinois, I'm not sure. These ratings are also posted on our crop protection network. I have them posted on my website as well. And these are taken from our national extension soybean pathologist group. So these are our ratings that we put together as a team. Keep in mind, 2 to 3 weeks of protection from those seed treatments. They're intended to give your seedling a little extra protection and get it out of the ground. They're not fumigating your soils. So if you get rain 4 weeks later, your seedling's at V3 or something like that and is sitting underwater, it can still get infected and suffer from some of these diseases. So keep that in mind. 2 to 3 weeks of protection, protecting that seed, getting it out of the ground. Now, another organism that we have that's an oomycete in Illinois and our surrounding states is Phytophthora. Very similar to Pythium in many ways. It has little swimming spores that can move in the water just like our Pythium. Really loves those saturated soils, but really warm conditions are going to favor this particular pathogen. So soils greater than 60 degrees Fahrenheit, it can infect throughout the season. Again, those early infections tend to be the ones that are going to lead to the most significant symptoms. Really difficult to tell this one apart from Pythium early on in the season. Easier to differentiate this later in the season, and that's because if we have susceptible cultivars that are planted in a field of Phytophthora, oftentimes you're going to see this canker develop. This is going to move from the roots up. And then if you see here at the top of this canker, there's a margin, but it's not really a clear delineated margin. It's kind of this gradual gradient. That's one way of differentiating this from some of those other diseases that could give this kind of look, like some of the other stem cankers, and perhaps even a Rhizoctonia in some instances, or Fusarium. The other thing, if you're pulling this out of the ground at this growth stage here, you see something like this with plants wilting. Those roots oftentimes are pretty much jet black, and you're not going to have any fine feeder roots on them. They're going to look awful, and they'll slide right out of the ground. And that late season canker can cause girdling of your stems and plant death later in the season as well. That's something you're not going to see from Pythium. Now, some of that same survey coming out of those samples that Dr. Medeiros' group pulled in 2016 and 17 and from the clinic in 2018. What you can see here, looking at each year, is that we have Phytophthora in all of our samples as well, in addition to Pythium. So we're dealing with both sets of organisms in all of these different samples. The most common Phytophthora here, Phytophthora sojae, that's the one everyone's familiar with. And then you have this one right here, Phytophthora sansomeana. Every year we have both of those, less sansomeana than sojae. And as I'm going to talk about in a second, that's going to kind of impact how effective our management strategies are as well. In general, the belief is that sojae is the more aggressive of the two pathogens. It's also specific to soybeans versus sansomeana, which actually can go to corn, and I believe Douglas fir as well. And it might actually have a wider host range. Not as aggressive though, but it still can cause issues for us. So the big thing with Phytophthora is that unlike Pythium, there is resistance to Phytophthora, and this is where we start to get a little confused sometimes in our conversations. So there's different types of resistance in plant pathology. The one that a lot of our, well, I shouldn't say a lot, there's two types you're going to find in a lot of our soybean cultivars. One is a field tolerance to Phytophthora, which is a general or partial resistance. That means it's controlled by a lot of little genes in the plant, and it acts kind of like a net, right? So it's going to prevent all of those different races or pathotypes of the pathogen to cause a lot of disease on the seedlings. So it's not going to outright kill, it's going to slow the development of that disease, allow that plant to grow and produce a crop, unless there's a lot of wet weather or it's just an excessive amount of pressure that can overwhelm this sort of resistance. This one, the caveat is it's active after those true leaves emerge. So depending on how fast your plants are growing, you're talking about probably a couple weeks before this kicks in. That means it's not going to be effective at those really critical stages when you're going from the seed that's imbibing water to coming out, where it's going to be very susceptible to the pre and post-emergence damping off part. Race-specific diseases or genes are more like doors, where they will completely shut out specific pathotypes of our Phytophthora and allow others in. So that's where the composition of the different pathotypes in the fields are important. So a pathotype, it just means it's say Phytophthora sojae that can cause disease on a plant that has a given resistance gene. So if we look here on the right, I've got an example of some scores that were given to soybean cultivars from one of these Seedling catalogs. And this is what you're going to be looking at. You'll have your resistance gene. That's going to be a race-specific gene, effective all the time, but only effective against certain pathotypes. And then your field tolerance, effective against all your pathotypes of Phytophthora sojae, but it's going to be partial resistance. So they can still get disease, it's just going to come in at a much slower rate. We look at the Phytophthora sojae that were pulled from those samples that Dr. Medeiros pulled. You can see right here, these are percent of those isolates that are pathogenic. 1K, which was very common, you're looking at about 60% of those could reproduce on plants that have that 1K resistance. That means that resistance is not working on those 60%. Also 3A, we're getting close to 50% that we were seeing here. So if we go back a slide and we're looking at some of these genes that are common in our soybeans, you can see that, yes, they can definitely provide some protection, but they're not going to give you 100% protection, especially if you have a field that's diverse and has many different types of pathotypes in there. And that's usually the case, is that they're very complex. We also screened these, or Danielle also screened Phytophthora sojae pathotypes here and saw that the sansomeana were not consistent in terms of their response, meaning that those resistance genes were not providing any kind of reliable or predictable control of Phytophthora sansomeana. Luckily, like I said, that one's not as aggressive as Phytophthora sojae, but it definitely can still be a problem. It's something we have to think about. So Phytophthora management, a little bit different than Pythium. The cultural practices are going to be the same, but if you've got a history of Phytophthora issues in your field, you want to be going out and selecting a variety that has good field tolerance rating at a minimum, and then probably going in and using a variety that has some sort of RPS gene associated with it, the 1C, 1K, 3A is the other one, or some of those that have stacked RPS genes, meaning that they have more than one. They're going to provide more protection against those. And then you want to be considering a Phytophthora fungicide seed treatment. That's going to be specific for Phytophthora. And I say that here because as you look at this rating, I've highlighted oxythiopyprilin here. Oxythiopyprilin is excellent against Phytophthora, but it doesn't work so great against Pythium. And that's one of the caveats. So when you're selecting your seed treatment active ingredients, keep in mind, what is your target? Is it Pythium? Is it Phytophthora? Can you combine some of these active ingredients and give yourself better protection? So keep that in mind when you're selecting your seed treatment packages. And also, as I mentioned before, keep in mind 2 to 3 weeks of protection gets you to that first true leaf. So if field tolerance is all you're dealing with, going after a seed treatment might be a good investment. Another one that we come across in Illinois quite often is Rhizoctonia. Rhizoctonia is caused by a real fungus, a true fungus, Rhizoctonia solani. There's lots of different species of Rhizoctonia out there that are very diverse. Always, it's never simple when it comes to plant pathology and fungi and fungal-like organisms. These guys tend to be problematic typically when we have warm weather and rain in fields with high organic matter. So a lot of these no-till fields, not so much saturated conditions. So these guys like it wet, but not necessarily underwater for a long period of time. They actually require that oxygen to get going and growing. But they're fairly frequent in Illinois soils. They will cause a pre-emergence damping off as well. Can't distinguish it at that initial phase very easily. That post-emergent phase is where you're going to be able to start seeing some of these cankers that develop under the hypocotyl. This is what that would look like in terms of a rating scale. And this is what you might encounter. They're oftentimes red, kind of corky or dry in appearance. They're going to be low on the stem, oftentimes very near the soil line. This is a great image here on the right where we're looking at some of these cankers, how they're actually sunken in and causing those seedlings to wilt, die, and fall over. So that's kind of what you're going to be looking for Rhizoctonia in the field. Late infection, very typical here, especially after drought. You're going to start seeing these yellow kind of wilty plants that won't hold up very well, shrunken, and that's where you're going to see these additional yield losses. A lot of these symptoms are also very similar in our other root rots as well, but we tend to see a lot of this wilting with our Rhizoctonia. It does tend to do better, and like I said, under those moderate to dry, warm conditions. So wet followed by a drought, that's usually a good condition for Rhizoctonia. There's lots of different what we call AG types. It just is an additional diversity level in our Rhizoctonia that we have. Add some layers of confusion. Basically what this means is that they differ in their host range. They're going to differ in their aggressiveness. When we look at Illinois, and we've looked at some of the work that's been done in maybe early 2010, 2011 or so, the one that we have the most of is this AG type 2-2. This is one of the more aggressive ones on soybean. Okay, so we do have a pretty good slug of the Rhizoctonia that we're dealing with. that can cause significant levels of disease in our fields. In terms of managing Rhizoctonia, again, similar to our other diseases. This one, you can actually rotate in some cases because, like I said, a lot of these Rhizoctonias, yes, they can go to corn, but the ones that go to corn aren't as aggressive on soybean as the ones that are on soybean. So rotation for a year or two out into corn might help in some cases and help reduce that inoculum. Reducing plant stress, herbicide burn, soybean cyst nematode, things like that are going to be important. There's actually some tolerance out there to Rhizoctonia, so that's something to consider when selecting your variety. And there's also Rhizoctonia seed treatments. So again, as you look at this list, those ones that were very good for our Pythium and Phytophthora, they don't do so hot here for our Rhizoctonia. And that's going to play a role in some of our other diseases as well. It's another reason why those base seed treatments are very important. Sudden death syndrome is one maybe we don't even realize this is a seedling disease because we're so familiar with the symptoms later on in the season, right? We're going in the season, we're looking at our plants at like R4, we start to see those leaves have that interveinal necrosis, and maybe they'll blight and those leaves will fall off. That's when we're thinking sudden death syndrome, right? That's very noticeable. It's these early season symptoms that oftentimes go unnoticed. We might blame them on one of the other organisms I just mentioned, or they could be in combination with some of those organisms. This is caused by Fusarium virguliforme. This is the only organism in the US right now that we've identified that causes SDS on soybeans. This one, unlike Rhizoctonia, likes it cool. So cooler is better for this disease, and it likes it cool and wet soon after planting, okay? So it needs that infection early on in the season to cause disease. Sorry, my 3-year-old broke my barricade. Early season seedling issues oftentimes, like I said, are misdiagnosed, underdiagnosed, but when you look at this, significant infections of the taproot, you're going to see those fine feeder roots are going to be eaten up and destroyed, and you're just going to have kind of like this black taproot remaining. So in terms of the amount of root rot and yield, all right, my wife pulled out of the room, sorry about that. In terms of root rot and yield, what's the impact? These are some examples coming from Iowa. And what we're looking at here are correlations. So this means it's a number between -1 and +1. And the closer you are to those values, the more of a 1-to-1 ratio there is. So in this case, the FDX is the foliar disease rating. Higher means more foliar disease later in the season. In these cases where there's higher foliar disease later in the season, and in this case, there was more root rot. And in this case, in the yield over here, you're seeing there's a negative relationship between yield. So that root rot can be very important in terms of late season disease as well as yield in some situations. So it can be impacting the stands as well as the late season impacts. So we do have some tools for managing SDS, as I'm sure you're aware. This is a disease that you're going to be managing with a combination of resistance and seed treatments. And I guess before I get too far in, identifying this disease I mentioned on the foliage, you're seeing that interveinal necrosis and chlorosis later in the season. That's due to a toxin that gets wicked up in the xylem, in the water conducting tissues, and it ends up accumulating in the leaves later on in the season. That also is going to be, you're going to be able to identify this organism if you take plants with that symptom and you look at the base of the stem, even the upper roots and the upper surface. A lot of times you'll see some blue growth, very blue, almost the same blue as my bars here on this graph. That's the actual sporodokia, the spores of this fungus growing on the tissue. And if you split those lower stems as well, you're going to notice that it's going to be kind of have this brown necrosis on the outside, the vascular tissue, but not the inside when you split those stems. That's going to help you separate it from other things such as stem canker, brown stem rot, and even red crown rot, which I'm going to talk about in a second here. So here on this slide, what we're looking at are the cultivar responses. This is coming from a study that was conducted through NCSRP funds. This was at Minnesota, Iowa, and I believe Canada, and they were looking at 10 site years, so there's a couple hundred observations here. Looking at the response of a moderately susceptible to a moderately resistant cultivar, and you can see these are planted in fields with SDS, that you're getting a yield benefit in terms of bushels per acre just by planting, moderate resistant versus moderately susceptible, and that's going to be related to that reduction in SDS that you're going to be observing. So selecting a cultivar with resistance can be important. One of the seed treatments that people are most familiar with is Alivo, and research has shown that that can help with our reduction of SDS in our fields. This is across those same sites, so you have 260 observations in this case. Looking across all the different levels of SDS severity that you might have. In general, when our average is about a 7.3% increase when we have SDS in those fields. Now, if we break that up and we look at the fields that are most severe and the ones that are least or less severe, because the Alivo can cost a bit of money, and we look at our return on investment, this is what we're looking at. So I like to kind of focus on the center part of this graph, $12 to $15. That's probably where you're at for an Alivo treatment, depending on what your deals are. These are commodity prices right here, $7, $10, $13, $16, but that would be nice if we got up to $16. And this is the probability of covering that cost. So you can see here in these areas where there's not a lot of SDS, you know, the probabilities are a little lower, especially at these low commodity prices. So in order to bump up our probabilities, we either have to drop our seed treatment cost or we have to bump up our commodity price. When we get into those environments where we have a lot more disease, okay, cool soils, planting early, really, really wet, history of SDS, that's where we see our those $12 to $15 seed treatments are going to become far more probable. We're up in the 80s to 90s here across all these different prices. So you're going to get the best benefit in terms of breaking even when you're utilizing Alivo in those environments that are really, really going to be susceptible or resulting in more likely resulting in SDS later in the season. Also, what we have here is, you know, we're trying to save money, so some people might actually go in and put Alivo on and not include a base treatment. Well, remember what I told you in terms of the fact that we don't manage one fungus, we're managing a complex of fungi, and depending on what you got, that might not be so good for you because fluopyram isn't very good at managing some of these other seedling diseases. It's very good for SDS. So in this case, we have SDS and Rhizoctonia. We went in and had a non-treated control, just Alivo, and then our base seed treatment. And again, I forget what was in there, but it was something that had an active ingredient that was very good at controlling Rhizoctonia. And then we had the combination like would normally be applied. And you can see here, just in terms of the population, significant improvement in our population over our non-treated and Alivo only. And when we include that base is very important, and that's also transitioning or translating into yields. So the Alivo is protecting against the SDS. The base is protecting against some of those other organisms, in this case, Rhizoctonia. So don't forget the base treatments. You might be saving yourself some money in one thing, and then you're ending up costing yourself money in another. So management for SDS, again, drainage, avoiding compaction, trying to plant into warmer soils, although if it gets really wet, it doesn't really matter, but typically the cooler it is, the worse it is. We like to say also with this one, manage soybean cyst nematode. There's quite a bit of evidence suggesting that when soybean cyst nematode is present, SDS is worse. It's probably causing more stress on the plant. There's also some evidence that this can overwinter in the cysts of soybean cyst nematode, which is kind of interesting. In fields with a history of SDS, maybe when you're going in, especially early, into maybe cooler soils, definitely selecting cultivars that have some moderate resistance, and then considering an SDS seed treatment. So the fluopyram, that's the Olivo right there, very good. And then there's this new one here. I'm not going to try to pronounce that. I'm not very good at pronouncing words like that, even though my last name might lead you to think otherwise. That's our Saltro seed treatment, and that one we also have rated very good as well. So that's another thing that you can consider for soybean cyst, or sorry, sun and dust syndrome. The last one that I want to talk about here before I finish up is red crown rot. Red crown rot is a disease that's new to Illinois. We first detected it in 2018 near Pittsfield, which is out kind of in the western part of the state near the Missouri border. It's actually hilly out there, not flat like it is in the central part of the state where we're at, or where I'm at. This is caused by a real fungus, Kalanectria illicicla. I call it the warm season cousin of SDS. So this one likes it really wet and warm, really warm. Okay, soils in the 70s to 80s is going to be optimal for this one. Nice saturated conditions. It's going to act very much like SDS, where it'll infect the roots, cause pre-season or pre-emergent and post-emergent damping off with kind of that black taproot. It also will produce a toxin later on in the season that gets wicked up into the leaves. Those leaves will then develop that interveinal necrosis. So it looks very similar to SDS. Another reason why, if you see interveinal necrosis in your fields, don't assume it's SDS. It could be a number of things. It could be red crown rot. It could be stem canker. It could be brown stem rot. There's lots of different things it could be. So you see that symptom, go out there and check. In this case, red crown rot gets its name because it can produce some pretty diagnostic features. Those little red structures are the spore-bearing structures of the fungus. They show up when the plant is starting to senesce. The base of the plants oftentimes are going to be covered in kind of like a white mat of fungal growth. That's typically going to be present in your fields, especially if it's wet. The lower stems kind of have a red appearance to them, might make you think that you're dealing with Rhizoctonia. When you split those stems in half, that center pith is going to be kind of gray and kind of, I don't know, dusty looking. So sort of like charcoal rot, but not really, and it's going to be at the base of the stem. So a lot of different symptoms than SDS, but you actually have to be looking to see some of these symptoms. Really, when you see those red dots, that's when you're going to, those red balls on the base, that's going to be your aha moment. But we are looking for more of this pathogen in the state. We want to see how far it's spread and how likely it is to cause risk to our producers, because we really don't know a lot about it, okay? This is a disease that we typically see in rotation with peanuts. Kalanectria also has an extremely wide host range on all legumes, so ornamentals, things like that. It's related to the pathogen that causes boxwood blight, if you may have heard of that particular pathogen. So why it's here, typically it's in the south. It likes it in warm weather. We know it overwinters here. We've demonstrated that. We don't have a lot of information on it. There aren't any cultivars that are resistant or tolerant to this disease, and we also have no information in terms of seed treatment. So we've started working on this through some funds. Thanks to the Illinois Soybean Associated, we're starting to get at some of this, and these are some preliminary results when we're looking at some of these seed treatments and their ability to protect our soybeans from germination-related impacts from Kalanectria illicicla. So you can see here quite a significant amount of reduction in our germination and our non-treated, so it just has the pathogen here. But we can definitely see that in these treatments here on the left, where we have our A's, they're all going to be providing the best control in terms of that germination. Some of these other ones not so well, and as you can see, their vibrance on the right didn't provide any protection at all, as well as that Ethos XB and Apron XL. and Myrtec didn't do as good for us. Those were probably the lowest in terms of this particular trial. And we're looking at just rotted seed, very similar story, where there's more rotted seed over here with those treatments that didn't do so well at the germination study. And over here, these were the winners in this particular study. So there's a lot of work that we have to do with this pathogen and figure out why it's here. How is it similar or different from Calanectria olicicla that they have with peanuts in other parts of the country? It's interesting because this is a disease that they're noticing ticking up a bit in Asia. So in, for example, China and Taiwan, those areas have had more reports of this disease lately. And how it got here, I'm not sure. But the fields where we found it last year, they were probably seeing about 25 bushel losses in those fields where it was prevalent. Pretty devastating there. So what can we do? Avoid continuous soybean production. Rotating to corn actually can be fairly effective, but you might need 2 seasons away from it. So although this one does overwinter, it doesn't overwinter as well as, say, Pythium or Fusarium virguliforme. So if you can go into corn a couple seasons, that could really drop down your amount of this pathogen. Managing your residue, again, going into corn, reducing that soybean residue is going to reduce the amount of the pathogen there. No varieties that have any kind of tolerance or resistance. So that's something we'd like to start looking at. And then labeled seed treatments, again, any kind of benefit you get from any of these seed treatments that I looked at previously, they're not labeled, so that would be like off-label protection. But we're looking at that. We're going to continue looking at that with ISA and hopefully getting some of the industry interested as well. But again, something to keep your eyes out for this season, especially when you're out in the fields later in the season, seeing some of that interveinal necrosis. So seed diseases overall, remember, they all need wet conditions, saturating soil, so drainage, compaction management is going to be important. Rotation's not always going to be great, but it can help you with some of these diseases. And I mentioned, if we're talking about red crown rot, that's one that can benefit from that. Rhizoctonia can benefit from that. So you definitely can see a benefit. Variety resistance tolerance, especially if you have been bitten in the rear end by some of these diseases, you want to circle back and see if you can select something that'll do better for you in those specific problematic fields or areas. And remember, those seed treatments will help pop those seeds out those first 3 weeks. But if you're getting heavy rains 4, 5, 6 weeks later, like we did in 2018, it's not the seed treatment's fault. It's just that you got a lot of water, and as long as that water's there, you're going to have problems. And remember, these guys are not going to be protecting your plants from drowning. So if they're sitting underneath water for several days, that's not something a seed treatment's going to protect your plant from either. So keep that in mind, and thank you again to the Soybean Association for funds for the work, as well as inviting me to give this talk, as well as the NCSRP for some of the funds that were used for Dr. Maduros and his Phytophthora work, and also for supporting the SDS work, and the University of Illinois for supporting some of the other Phytophthora work that Dr. Maduros and I have conducted. With that, I will conclude my talk, and I will leave it to the Wrangler. If anyone has any questions, I can answer those questions at this time.
Excellent job, Nathan. Thank you very much. We do have some questions that came in, and I'll go down a few of these, and we'll have you address them. So question number 1, how effective is our seed treatments on soybeans after the seeds have soaked up water and treatments start to crack?
So it depends on the seed treatment and the active ingredients that you're using. Some of those seed treatments are going to be more mobile than others, and so they're actually going to be taken up by the plant, and they're going to move into the tissues of the plant. In fact, that's why you see with Olivo, you see that halo effect that they talk about, right? That's actually the fungicide can be moved up into those cotyledons and can accumulate a little bit and burn. And so for those that are mobile, they're going to have, I guess, what I would call a little longer shelf life than some of those that are not as mobile and are only active right around the seed itself. In general, our seed treatments are going to be binding to organic matter. The more organic matter you have in the soil, the less likely those seed treatments are going to move in your soil. So that can play a role as well. But I would say in general that 2 to 3 week window is going to be fairly consistent across all the different seed treatments that we're dealing with, even if the modes of action and mobility in the soil might differ somewhat.
Excellent, thank you. The next question, I believe it was referring to specifically Pythium, but a lot of active ingredients have a range of rates as far as effectiveness. What ranges of rates do you recommend or would you like to see?
That's a really good question, and to be honest, I haven't seen a lot of data where people are actually comparing different rates of a lot of these other seed treatments. With the SDS, they've kind of locked in that, you know, there's an SDS rate and there's a nematode rate, and that lower rate seems to be pretty effective for managing SDS. You know, I would say if, and again, I'm not the one putting the seed in the ground, but if I was going into a field that I felt was at a high risk for, let's say, I don't know, Pythium, and was planting early, and I felt like I've had issues in the past, it might be something to consider if, you know, you want to bump up that rate to give yourself a little extra benefit, especially if it's overwhelmed early. But just keep in mind that the duration of the control is still going to be relatively similar. You're still going to get that, you know, 2 to 3 weeks of protection. It's just it's going to be a little stronger. So hopefully it can slow down things if it gets overwhelmed with some of these fungi. So it's kind of a winding answer to your question. It really depends on the situation and what the history of the field is and what your risk levels are.
Okay, excellent. The next one, are there any reliable ratings for forms of biological control of seedling diseases, specifically trichoderma?
Reliable ratings for those. There's been some work conducted on those. The biggest issue with the biologicals is that they're very variable, and it's hard to get good, clean data from them in the field. So for that reason, I think we don't have a lot of information on those, at least from our soybean extension group. And a lot of the work we've been conducting has been focused more on the synthetics. You will find some ratings probably based off of some pot assays, maybe microplots, but large field scale trials are relatively difficult to come by. There probably are some people that have looked at that, but I personally have not.
Okay, excellent. And our last one is referring to the slide on the let's see, the seeding rates and germination of the seeds at the Monmouth site, where you're comparing the base seed treatment versus base seed treatment plus the Olivo study.
Yeah. Okay, so what's the question then?
So the question is, what was the seeding rate of that study, and what was the germ of the seed that was utilized?
So our standard seeding rate, it would have been 145 to 150 probably. And the germ on that, that's a good question. I'd have to go back into our notes and see what the germ was. At this particular site in Monmouth this year, it was really dry. So, I mean, that particular site was like concrete, probably around the V3, V4 stage. So it got really dry and hot at that particular site.
Okay, excellent. Well, that is all I have for questions. Do you have any other comments you'd like to make?
No, just that, you know, we are looking for red crown rot, and if anyone's interested in participating in any kind of survey or helping out with that, to let me know. And also that, you know, my information here at the front of this talk, that is for you to use. Contact me however you'd like, whether it's through there's those rat tail pictures again, through the through the email, Twitter. You can get my telephone number. You can call me anytime. Also, I try to put as much information as I can up online in various ways of getting that information out to you outside of webinars. So you feel free to contact me with any kind of questions or issues that you have throughout the year. That's why I'm here, and I'm happy to do so.
Nathan, thank you so much for your time and knowledge this morning. So with that, that concludes our webinar this morning on seedling diseases can keep soybean plants from popping. Our next Soy Advisor webinar will be May 12th, and you can register for that event or view the upcoming and other recorded presentations and other soybean agronomic resources at the checkoff-funded website, lsoyadvisor.com. Thank you for attending and have a great day.